Thank you for downloading this podcast. If you like to put your thinking cap on every now and again, you could be the next brain of talk radio. Get to 702.co.za or capetalk.co.za for more information.
Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clappy.
Good morning to you, Chris. Lovely to chat to you again. Thanks for joining us.
Morning, Rudy.
All right, so our lines are open for you on 021 446 0567, 011 883 0702. I know there are lots of you who are still phoning about the rape campaign, and yes, that will be an ongoing conversation on the station throughout the day, and Dr. Eve and I are going to tackle the matter after 10 o'clock. Those of you who are holding on to ask your questions or to comment on the rape campaign, we will take your calls just after 10 o'clock. But right now, it is that time where we are taking your calls and any questions on your on science, technology, geography, biology. We are stripping science down to its bare essentials as we try to understand the world around us. Chris, I have an email here from a concerned mother who wants to know what. Obviously, alcohol causes alcohol poisoning, but she wants to know what actually happens when somebody suffers from alcohol poisoning, like Amy Winehouse, I suppose. When do you move from being extremely inebriated to being poisoned by alcohol?
Well, alcohol is a poison, and luckily we have a liver that deals with it, and the liver has enzymes, which are tiny protein machines that can dismantle the poison and turn it into things that are less poisonous and then remove it from the body. Unfortunately, in the course of dealing with the poison, some cells in the liver do get damaged or injured. And this means that if you drink too much too often, then the liver is continuously being injured and it can suffer permanent damage. The kind of damage that you get is initially you get a fatty liver. And this is because the energy that it takes to break down the alcohol, instead of being used to deal with fats, you rob the metabolic pathways that would deal with fat and use them to deal with the alcohol, so the fat just builds up in the liver. And this, in turn, can damage the liver cells. In the longer term, if you keep injuring liver cells, then you have to replace them. And there are liver stem cells that can grow and make new liver cells. But at the same time as replacing those cells, you also build up fibrous tissue. And this means that the liver becomes hard and fibrous instead of soft and spongy. And this is the first step towards what we call cirrhosis. And when you have cirrhosis, you actually don't have a big liver, you have a small shrunken liver, which is mainly all this fibrous tissue and lots of little islands of liver cells that still work. Mm-hmm. But because there's so much loss of liver tissue, the ability of the liver to actually process toxins, including alcohol, is dramatically reduced. And also the pressure of blood trying to pass through the liver, because normally you've got a very big liver picking up all the blood that's flowed through your intestines and putting it back cleaned up into your circulation. If you don't have enough liver tissue there, then the blood can't go through fast enough and you can get a backlog, and this causes other problems for blood vessels that can bleed in your intestines, and also fluid can build up. And over time, this then has other issues, such as if you have cirrhosis, there is a risk of getting liver cancer. Now, this is a long way down the line. There are also lots of psychological problems, because if people become dependent on alcohol, they're usually becoming dependent on it for a reason, and it becomes a genuine addiction, and the brain gets used to having alcohol there, and alcohol is a depressant. It reduces the activity of nerve cells in the brain, and so people get used to having that depressant drug there, and they can't function normally without it, and if it's suddenly withdrawn, they can actually have life-threatening seizures and fits. So why do you get this happening in the first place? Well, some people start to use alcohol more than just recreationally as some kind of crutch. There's things not working so well in their life, and alcohol cushions them against those insults, and so they increase their intake of alcohol. The insults don't go away and they feel better, so they sustain that, and then it becomes an entrenched behaviour. And some people appear to be more prone to this than others, but it can really affect anybody.
Okay. Chris, let me just bring you on board. We have started an anti-rape campaign here at 702, and part of the rollout involves these beeps that are supposed to just jolt people into awareness about this, the scourge of rape in our country. It is absolutely horrific. And of course, we throw some rape facts and statistics and hearing from people who have been victims as well throughout the day. That's what we're going to do. So if there is the slight interruption to our conversation, it's precisely that. All right, our lines are open for you on 021 446 0567 011 883 0702. Rian in Menlyn, hi.
Hi there, Reedy and Chris. Chris, a question. If you strip out all the Higgs boson particles from a spaceship, will it therefore become massless and then theoretically be able to speed it up to the speed of light because it no longer has mass, which is your biggest resistance to get it up to speed of light?
It's a lovely idea. I'd not thought of doing that. Maybe I should put that to the people at CERN. I don't think that would work because, in fact, the way things actually operate, we think, is that you have this concept of a Higgs field in the universe. And when matter comes along, in other words, atoms and stuff that things are made of, it interacts with that field, and the field gives it the function of mass. So the Higgs bosons are the mediators of that field, which exists anyway. And it's not like it's in stuff and you can remove that bit and the stuff then subsequently has no mass. The Higgs field pervades the universe, and things are, as they travel through the universe, interacting, if they're made of material, with that field, and that is what gives them their mass. So you couldn't get one away from the other.
Thank you very much, Rian. Thank you, Rian in Menlyn. I have an SMS here from Steve. Says, please ask Chris if evolution can explain how it came about that a spider spins a web to catch its prey. Okay.
Well, there was quite an interesting story which was published a little while ago, last month, on mice. And there were these researchers in America studying two different types of mouse, which are closely related to each other, but they aren't actually the same species. And one of these mice makes a straight tunnel about 1.5 meters long into a sandy bank. And the relative, called a deer mouse, makes a tunnel into the bank, which is about 2 meters long. And at the end of the tunnel, it then digs an escape tunnel upwards to almost to the surface. And then if a snake or something goes into its hole, it can dig through the bit at the top and escape. Now, the scientists wondered why this behaviour comes along and what causes it. And so they did some experiments where they mated the two different species of mouse together to see what sorts of tunnels their offspring would produce. And when they did that experiment, they initially got offspring that produced tunnels that all had escape shafts but were much shorter on average. Mm-hmm. And then when they mated the offspring with one of the parents again, they got animals that only made those escape tunnels 50% of the time and made on average tunnels that were much shorter. And this enabled them to then track down the genes in the animals that were causing those behaviours to happen. And they found that they found 5 genetic regions that make this complex behaviour happen in these mice. And this tells you that genes directly lead to the way the brain develops, and the way the brain develops controls the behaviour of the mice. Digging an escape tunnel is a pretty complicated task, and having genetics that you can track down and find the gene elements that make that happen is a pretty outstanding discovery. It was published in Nature just last month. So if a mouse can do that, it's not surprising then that a spider can similarly carry genes that will tell it how to behave to make a web. And this will be because those genes tell the brain how to wire itself together, and those nerve networks, which are hardwired into the spider, will tell the spider how to make its web under certain conditions and how to do the behaviours that lead to that web. How did it get that behaviour? Well, it would have started with a rudimentary web, which wasn't particularly good at catching stuff, and a spider that happened to have the ability to make a slightly better web would have had more success, and therefore probably would have eaten more and been a healthier spider, so it would have mated more often and had more offspring, all carrying that trait genetically. And those spiders would have started from a position of strength and then changed their genetics over time to build an even bit better web. And so the spider webs we see today are the product of millions of years of gentle adaptation driven by natural selection to arrive at the web shape we see, underpinned by genes that cause the spider to do that.
Ah, very interesting indeed. Rory and Sean, please stay on the line. I'll speak to you right after this. 11 minutes to 10 o'clock, and we are with the Naked Scientist on 021 446 0567 011 883 0702. Rory in Bryanston, hi.
Hi, Rudy. Hi, Chris. My question's really in relation to some discussions that you've had recently with Tim Noakes on his high protein, high fat, low carbohydrate diet. And basically he's saying that if you are insulin resistant, this would be a very beneficial diet for you to go into a high protein, high fat diet. I just want to understand what insulin resistance actually is and how do you know if you've got it?
Okay. Insulin resistance.
Hello, Rory. The answer to this is that when a person eats something and their intestines break down the carbohydrates in what they've eaten, and carbohydrates are molecules which are in the simple form sugars, or in a more complicated form sugars stuck together to make starch. When you eat those starches, and in some cases from fungi glycogen, which is a bit similar, you break the starch down into simple sugars like glucose, and the intestine absorbs those and puts them into the bloodstream. And they go around in the bloodstream, including through the liver, and cells can pick up glucose and push it inside themselves. And glucose is an excellent fuel for cells because it goes straight into the first step of the almost universal energy pathway in cells called glycolysis, which turns the sugar into energy molecules. Now, in order to get the glucose into the cells, you have to have a transporter. It's a bit like a revolving door that the glucose goes into, and the revolving door spins round and puts the glucose inside the cell. And because the amount of glucose in the cell is probably higher than the amount of glucose in the blood, you have to have an active process. You can't just rely on the glucose finding its way into the cells. You need to pump it in. And in order to pump it in, you need a signal to do that. And cells have on their surface receptors. In other words, these are chemical docking stations for the hormone insulin, which comes from the pancreas. And when the insulin binds to those receptors on the surface of the cell, it triggers that revolving door to turn on and draw the glucose inside the cell. Now, in a person who's healthy, that's the status quo. But in people who become insulin resistant, for some reason that we don't really understand, although there is a paper in the journal Nature this week which implicates one particular gene in this process happening, the cell's response to insulin becomes much less. In other words, in order to get the revolving door pulling the glucose inside the cells at the rate it should, you need a lot more insulin than you would do normally. So when people are are overweight, for example, they become what we call insulin resistant, because if you measure their glucose levels, they may be at the higher end of normal, but their insulin level will be very high, and we regard this as a pre-diabetic state. In other words, it's a warning sign. If you can get your weight down, this should improve the sensitivity of your cells to insulin again, and your glucose level will also follow. But that's what insulin resistance is.
Okay, Rory, is that clear to you?
Yeah,
Okay.
absolutely.
All right. Thank you very much. Thank you. That's Rory in Bryanston. Let's go to Nick in Johannesburg. Hi.
Hi, Rudy. Chris, fluoride is in tap water and bottled water and toothpaste. And there was a recent study in Harvard Harvard study saying that fluoride does a hell of a lot more damage, but I mean quite significant damage than good. I just wanted to get your take and maybe understanding of fluoride and pros and cons to it.
Okay, well, fluoride is at the top of group 7 in the periodic table. It's a molecule, it's an atom, a bit like chlorine and iodine. It's one of the halides, or halogen elements. And the reason that we tend to come across fluorine is in toothpaste and drinking water, because our teeth are made of a tough mineral called apatite, and it's a form of calcium phosphate. If you add a fluoride into that matrix, you get fluoroapatite, which is even harder and even tougher, and therefore your teeth are much stronger than they would be normally. So when people realise that tooth decay was a big problem, and if we put fluoride into toothpaste or into drinking water, it will get onto the teeth and developing teeth, and it will strengthen them. This saw an improvement in tooth decay states, and everyone thought that was great. The only problem is that when you're exposing yourself to the fluoride in the toothpaste, there is going to be systemic delivery of fluoride. In other words, there's going to be fluoride going all around the body. So what people want to know is, when you put the fluoride into your body, although there's a beneficial effect on your teeth, is there an equivalent effect in the opposite direction for other tissues? And at the moment, it's not really clear. There have been a number of studies done, and I'm not an expert on this, so you cannot take what I say as gospel. All I can do is to say that there are studies that you can read. There was a very big, what we call meta-analysis, where you draw lots of studies together, done by scientists at the University of York in recent years. What they discovered was that there was no clear indication of any health disbenefit associated with fluoride. They tested various hypotheses, such as, does fluoride cause cancer? Does it cause bone problems? And I don't think the evidence that was there was strong enough to make any recommendations one way or the other.
Thank you very much, Nick. Can we go to Kiu Shebile in Parktown?
Hi,
Hi there.
and Chris. How are you?
Yeah, your question?
Chris, I just wanted to find out, is it possible for a baby to be born with the scar that a parent has acquired?
Inherit the same birthmark that your parents have?
Yeah,
not birthmark.
A scar. Say you're in an accident and you got a scar or whatever. Will your baby? Is it possible for a baby to acquire that?
Without being in an accident herself or himself?
No. Say you conceive a baby after the accident.
And you've got a scar?
Yeah, and you've got a scar. Is it possible for the baby to...
Okay.
Yes,
right.
I understand what you mean. The answer is no. And the reason is that when a baby is born, it's a single cell, an egg, which has been fertilized by a sperm, which then divides millions and millions of times to produce the trillion or so cells which make up that baby's body. And those cells follow genetic instructions as to how to put themselves together. The scar that the adult gets, or the injury the adult gets, does not alter the genetic information written into the egg or sperm in such a way that it would change the way the body puts itself together. And in fact, scientists did wonder whether experiences of adults would translate into changes in babies about 100 years ago or so. And there was this one theory, it's called Lamarckian evolution, that changes done to adults or things that happen to adults would be reflected in the development of a baby. And one of the studies that they did was to chop the tails off mice and rats for many generations to see if the offspring would slowly evolve to have shorter tails. And they didn't. And it was a rather flawed experiment because, of course, anyone who is circumcised has a parent who is circumcised and so on knows, and Jewish tradition and Muslim tradition has been doing this for thousands of years. The fact that babies are not evolving, if their parents have been circumcised for generations, to not need circumcision tells you that if you have changes to the outside of your body, this is not reflected in the structure of a newborn baby's body.
Wow, very fascinating. Okay, so, it feels like it was short today. It feels like our conversation with the Naked Scientist was short. I'm going to sulk. Chris, thank you very much. We'll speak to you again next week.
All right then, well, I'll look forward to seeing you next time.
David and Nelson, I'm sorry we couldn't take your calls. I promise you'll be our first callers next week, Friday.